A car has mass 1,000 kilograms. Its engine produces a traction effort or driving force of 2,500 newtons. There is resistance to motion of magnitude 500 newtons. The car starts from rest. Find the acceleration of the car. Okay? So what we're going to do is we're just going to make a little diagram of what's going on. You have your 1,000 kilogram car. Okay? Now, its engine is driving it forward at 2,500 N. There's resistance to the motion of magnitude 500 N going in the opposite direction. Okay? Now, can anybody tell me which direction is it going to go, left or right? Right. And what's the force it's going to be driven right at? So that's very evident. Like, you just take away the forces. One force outpowers the other force. It's going 5,000 newtons to the right. Okay? Now, the next formula you're going to need to know, this formula is everywhere right, in this course, is F equals ma. Force equals mass by acceleration. Your force is going to be 2,000. Your mass is 1,000. And your A is there. So look, A is going to be 2 meters per second squared. Any questions on that? Reasonably easy, okay? Now, once you've done that, what's going to ask you is how far will it travel in the first 20 seconds? Now, because it's a constant acceleration, okay, it doesn't change. It doesn't state that these 500 newtons change, and it doesn't state that the 2,500 output of your engine doesn't change either. So it's what's called a constant acceleration. Therefore, it obeys linear motion, UVAST. UVAST. Does it start from rest? 0, whatever, 2, 20, ut plus a half at squared. S equals ut plus a half at squared, which is going to be 0 plus a half times 2 times 20 squared. A half, just going to be 400, isn't it? 400 meters. So look, very bargain basement question to begin. Let's keep moving. Question 3. A bicycle has a mass of 60 kilograms. If its rider has a mass of 90 kilograms, so you're just going to have a 150 kilogram object. It's a really fancy trick to make you add both weights together and give you exactly the same question. Okay, so air resistance is minus 40. Find the driving force D needed to accelerate the bicycle and rider with an acceleration of a half ms 2. If the rider's mass is doubled, find the force needed for the same acceleration, assuming the resistance remained the same. So it's a bit of a change up from the first one, okay? So what we're going to say first of all is that the net force, F equals ma, and the net force, F, has to be equal to 150 kilograms multiplied by a half, because your acceleration is a half. The net force therefore is 75 newtons. What this means is that your D minus your 40N, or D minus 40, has to be equal to what? 75. That makes your D 115 newtons. Okay, are we happy with that? Now, you go to the second part of the question, and it goes, if the rider's mass is doubled, find the driving force needed for the same acceleration. Okay, for the same acceleration, okay? So, instead of, I was about to double the 150, which would make me completely wrong. I'll just have to double the 90 to get 180 plus 60. 240. So instead of having a 150 kilogram guy, instead of having a 150 kilogram system, we're going to have a 240 kilogram system. And then you just use your old question, you just change that to 240, which changes that to 120, which changes this to 120. And as predicted, you're going to need a much larger driving force to propel a heavier man at the same speed. So that's going to make that 160. Very good. Everybody happy enough with that? Moving on. Let's get this a bit. Let's move this up a little. Now, bullet. A bullet of mass 60 grams is fired horizontally, so it enters a block of wood. So comes in here, and just before impact, we're talking that it's going 150 into the wooden block. It's going to what type? It's going to if the resistance of the wood is uniform and of magnitude 600 N, we're assuming a constant resistance. So the bullet's going to eke its way in, and then eventually it's going to become lodged, or in some cases it can go straight through. Now I think we're assuming how far into the wood would the bullet penetrate. So we're assuming a still be long part of wood that the bullet isn't coming out. Alright? So what we're going to do here. Okay? So look at the forces on the bullets. Okay? Now, because the bullet is a projectile, there is no driving force, so you only have force going to the left. Okay? So you're talking that it's 900 newtons to the left. That's your only force. Okay? So F equals ma. It's technically a deceleration, isn't it? So technically it's minus 900. So minus 900. Now, because it's in newtons, what does that mean I have to do with grams? Change it into kilograms, because newtons is actually measured in kilograms as well. So remember, force is mass by acceleration, which is kg meters per second. That equals 1 newton. So because we're using kilograms here and we're using newtons here, we have to make sure that everything's in its standard units, which is kilograms. Okay, so we're going to change the it's not 0.6, it's 0.06. So 0.06 kilograms. So it's 0.06 kilograms multiplied by A. Divide the 0.06 into 900. Minus 900 divided by 0.06, anybody? Minus 15,000 ms to the minus 2. Minus 15,000 meters per second. Quite a drastic deceleration, okay? Now, how far into the bullet will it penetrate? Any ideas what to do there? You've asked. U is 150. Phi is, anybody? 0. Your acceleration is minus 15,000. Your S is what we're looking for. T, we don't care about. Phi squared equals U squared plus 2AS. Your 150 squared equals 0 squared plus 2 times minus 15. Wrong way around? Okay. Your 0 squared equals your 150 squared plus 2 times your minus 15,000 times your distance, which is what we're looking for, S. Bring this whole minus 30,000 S over the other side, so 30,000 S equals, I don't even have to write down what 150 squared is, just no point. S equals 150 squared all over 30,000. And when you put that into the calculator, pretty sure it comes out to be 0.75 meters. Does it ask for it in centimeters or anything like that? 75 centimeters or 0.75 meters. Okay. Good with that? Moving on. Starting to get a bit harder now, okay? Okay. Similar question, but it's like it's giving us different parts of it this time. It's not giving us the same lead in, okay? So, first of all, a bullet of 0.05 kilograms is traveling horizontally at 200 meters per second. Enters the wood and travels a distance of 1 meter into the wood. Find the resistance of the wood, assuming it is uniform. So we're going to start off with UVAS this time. S equals 1, A equals what we're looking for, phi equals 0, U equals 200, T equals whatever. Phi squared equals U squared plus 2AS. 0 equals 200 squared times just 2A, isn't it? 2A. Now A is going to be negative. Okay. What's 200 squared? Thank you. Minus 40,000 equals 2A. A is going to be minus 20,000. MS to the minus 2. Now that we've done that, what we're going to do next is find the resistance of the wood. We haven't found that yet. So F equals MA. F equals your 0.05 times your 20,000, which will get me minus 1,000 newtons. So your net resistance is minus 1,000 newtons. Okay, because remember when the bullet enters the block, there is only deceleration. The bullet's a projectile and it hasn't got a motor in it, so it has none of its own force. The only force it experiences is the slowing down force. Okay. If the bullet had been traveling at twice that speed, how far into the wood would it have penetrated? Okay. So U equals 400, phi equals 0. A equals, the deceleration would have to still be the same. Okay, so it'll still be minus 0.05. S is what we're looking for now. Oh yeah, that'd be a really slow deceleration for going into a block. Minus 20,000. And phi squared equals U squared plus 2AS. And 0 equals 16,000 this time, is it? Was it? Or bigger again, is it? What's 400 squared? Oh, 160,000. And then 2AS is going to be, that's going to be minus 40,000 S. Divided in, and we get S equals 4 meters. So 40,000 S equals 160,000. S equals 4 meters. Good with that? Moving on. This is our first honours question today. So the rest of them were, unfortunately enough, past level applied maths. Okay. So a bullet is fired horizontally at 300 meters per second. It enters a fixed piece of wood which is 10 centimeters long. That 10 centimeters long has to go. It's now going to be turned into 0.1 meters. Emerges at 200 meters per second. Its resistance of the wood is 25,000 newtons. Find the mass of the bullet in grams. Okay, well, you've asked again, isn't it? Except to change it higher into an higher level question, all you have to do is just don't stop it. Okay, so basically what I mean by that is 300 in, 200 out. We have to find out what the A value is. What's it? Find the mass of the bullet. So that means finding the A value. We know the S value is 0.1. Phi squared equals U squared plus 2AS. So 300 squared. Oh wait. 200 squared equals 300 squared plus 2 times A times 0.1. Would somebody tell me what 200 squared minus 300 squared is? Anybody know? 200 squared minus 300 squared? Let's go with minus 50,000. Everybody agree with that? Yeah. Now, divide A into that, and we get A equals, A is going to equal minus 2,050, 250,000 ms to the minus 2. Now, what we're going to be asked for next is, we're asked for the mass of the bullet, weren't we? Whole question is about the mass of the bullet in grams, not kilograms. Okay, so our answer will be in kilograms. We are looking for grams. F equals MA. We're told that F is 25,000. We're told that we're looking for M, and we're told that our A is minus 250,000. I'm pretty sure that's going to be 0.1, isn't it? For M. And 0.1 is 0.1 of a kilogram, which is 100 grams. 100 grams equals M. Happy enough with that? Now, 100 grams equals M. What's the shortest piece of the same wood which could have brought the bullet to rest? So we go back up to UVAST. What do we need to change, guys? The V value is 0. The S value no longer applies. The A value, okay, so phi squared equals u squared plus 2as. 0 equals 300 squared. 2 times 250,000 is 500,000. Now, what is 300 squared divided by 500,000? Sorry? Any ideas? Can't do it in your head, no? So, I think it's going to be 0.18. And 0.18 of a meter is what? It's going to be 18 centimeters. Okay, step up from what you were doing earlier. Okay, next one. 12. Golf ball of mass 7 kilograms falls vertically and lands at a speed of 1.4 meters per second on a marsh. If the resistance of the marsh is 2.1 newtons throughout, find the depth to which the ball will penetrate before the mass comes to rest. Now, what's the difference between this one and the bullets? There's a big difference between going horizontally into an object and going vertically into the object. Can somebody tell me what the difference is? Gravity is driving us down. Okay, so when your golf ball is on its way in, it's driving its way into the marsh, there's two forces at play. Okay, so yeah, the first one is the force of gravity is mass by acceleration, but because your acceleration is gravity, it's mg. What is mg? Your weight. The weight of the object acting down and the resistance of the marsh acting upwards. Okay? Resistance of the marsh is your 2.1 n, and your weight. Now, would you suspect that your weight will be smaller than 2.1 or bigger than 2.1? Smaller, reason being, according to the language of the question, it's going to stop. If W is bigger than R, it isn't going to stop. It's going to keep going down forever. Okay? Until it hits a new object that hasn't got, but that isn't a marsh. Okay? So what we're going to say here is that weight equals mass times gravity, which is going to be 1/7 times 9.8. 1/7 of 9.8. 1.4 newtons. Okay. Now, what's your net force, lads? Excuse me, guys. Net force is going to be 2.1 minus 1.4, which is going to be a net force of 0.7 newtons going upwards. That's gravity taken into consideration, okay? Now, your net force also equals ma. So your 0.7 equals ma, which equals 1/7 of a. So 7 multiplied by 0.7. I think we're going to get a 4.9, is it? So 4.9 ms to minus 2 equals 8. Now this 4.9 is resisting the motion. So when we enter that into UVAS, is it going to be plus 4.9 or minus 4.9? Minus 4.9, because it's resisting the motion. What's our U value? 1.4. Our V value is 0. We're looking to see how far into the marsh we go, which is S, and T we don't know. So we're looking for S. V squared equals U squared plus 2AS. 0 squared equals 1.4 squared is 1.96, isn't it? Hopefully. 1.4 squared being 1.96 plus 2AS, which is going to be 2 times minus 4.9 times S. So our we're going to get a minus 9.8S, because 2 times minus 4.9 is minus 9.8. Bring the minus 9.8 to the other side. Is going to equal 1.96 divided. What's 1.96 divided by 9.8? Anybody? Let's go with 0.2 or a fifth. So 0.2 meters deep.